Hello everyone, my name is Gabriele Quaresima, and today we are talking about CloudNativePG. So yeah, who am I? I'm a staff engineer in EDB, and I show a list of things I love. And there are also my wife and my daughter, but yeah, also the music, coding. Just a little survey. How many of you use Kubernetes? I think everybody in the room, but this is easy. How many of you use Kubernetes operators? Okay. How many of you use Postgres? Wow. How many of you use Postgres on Kubernetes? And I will stop with the okay. Nice. So I can speed up a little bit on the slide, but not too much. So, okay, CloudNativePG is a CNCF sandbox project. It is an open source operator and is designed to manage PostgreSQL workloads on any supported Kubernetes cluster. It defines a new Kubernetes resource called cluster, again, cluster and cluster and cluster everywhere. And this cluster represents a PostgreSQL cluster made up of a single primary and optional numbers of replicas, usually 2 replicas. So PostgreSQL is a database management system. It's one of the most famous. It is free. It is started in the 1997, so it's about 30 years old. And yeah, it has a liberal license, and I think, yeah, it's very famous. And the top things that I can show you related to Postgres are obviously the features and the power of the extensibility. That is a nice thing. Also, developers love Postgres. There are a lot of surveys, and yeah, we love it. So let's talk a bit about the other piece I need to show you before to dive into CloudNativePG, that are the Kubernetes operators. So basically, there is a user modifying a custom resource, and there is an operator watching this custom resource and adjusting the desired state with the Kubernetes API server. So in a nutshell, Kubernetes operators are software extension to Kubernetes. You extend Kubernetes. So you use custom resources to manage your own application. So the Postgres cluster will be our CRD, custom resource definition. And the operator can implement and automate common day 1, day 2, and so on operation. We will see them better later. And you can abstract your own resource, so you don't interact directly with the Kubernetes primitives like pods or deployment on services, but you let the operators doing this stuff. So this is another picture of the control loop. So you have a declared desired state that you reconcile, the operator reconcile the control loop, and it will be reflected in the current state. These are the Kubernetes operator capability levels. From the level 1 to the level 5, we have a lot of feature and capabilities that you add. And CloudNativePG is a level 5 operator, so we will have all of this. You can write your own operator. There are plenty of SDKs. CloudNativePG is written in Go because, yeah, we like Go. Kubernetes is written in Go. But also you can have SDKs on any language. Yesterday I attended a talk, there was a Java SDK for operators. So it was very interesting. Perhaps this is the most important slide. So yeah, I like to show these 2 giants in comparison, and how they can interact, so we can bring Kubernetes to Postgres, but also Postgres user to Kubernetes together with CloudNativePG. So this is an example of a of the minimum CRD that we can apply, the minimum manifest. So we have the kind is cluster, we have a name, we define 3 instances, and just the storage size. That's it. There will be a lot of other stuff that will be enforced by the operator inside the cluster. There will be webhooks, there will be defaults, there will be a lot of stuff. And we will see them. This is a suggested architecture. So we have 3 nodes, we have a primary, 2 standbys, we have a service, actually more than one, one in the picture, but more than one. So we have read-only services, read and write services, and this is kind of the default architecture. CloudNativePG directly interacts with the PVCs. So this is, I mean, one of the difference between CloudNativePG and the other operators. So yeah, also the container storage interface for PVC allows to support the volume snapshot, backup and restored, if your own CSI driver and the storage class support them. And yeah, they are mounted into each pods and directly managed. This is a list of the main features like the high availability, the planner switchover, scale up and down capabilities, declarative management of PostgreSQL configuration, but also declarative tablespaces, databases, publication, subscription, and I can add also the puller, the PG bouncer. So we try to push everything on Kubernetes, so to rely on the declarative way to use stuff around. And also, yeah, we have backup on Volo Snapshot and Object Store, relying on Barman. And there is also one of the latest functionalities that is the major Postgres offline upgrade. And also, there is this new way to consider the operator like a core, and via the CMPGI, you can define your own interface, your own plugins. This is an important architecture in which you can have a PostgreSQL topology with replica cluster. So basically, you can see how is it possible and feasible to support a replica cluster switchover with this also. So you can define 2 different replica clusters, and you can also apply a switchover if needed, and it's very, very powerful. Like I said, we have a CRD to use PG bouncer if you need to support connection pooling in front of your application. The installation can be via the manifest from the GitHub repo, or with the OLM if you use OpenShift, or via the Helm chart. There is no operator without operand, so operand images are very important, and we build them directly from the PGDG supported version across multiple architectures, and also we add something like, in this AI time, we also add, for example, a PG vector, like an extension in our based image. Also, another important topic is observability. Yesterday, I think I saw 2 different talks about observability. All the logs are in a JSON format. We offer metrics, Prometheus exporters. So, and then you can attach a Grafana dashboard, but also you can extend those metrics and define your own metrics. And also there is a CMPG plugin for kubectl that can add also more logging. Not only that, also you can perform some imperative or declarative operations. But yeah, in this case is because of the status command. We will take a look later in the demo. This is, yeah, a picture of the plugin, some of the commands that we can provide. This is a slide that I recently had, what I personally love. I love the massive suite of end-to-end inside our pipeline, the documentation, the team members, my colleagues, and also, yeah, the community enthusiasm is another important thing. And this picture shows some of the maintainers running a demo at the project pavilion of the latest KubeCon. CloudNativePG is production ready, is a CNCF sandbox product, like I already said, and is becoming the de facto standard to deploy PostgreSQL in Kubernetes. The license is 100% open source. It has been originally created by DB and given to the community, and then to the open source community, and now since January to the CNCF. There are a lot of great companies like that adopted CloudNativePG, like Google Cloud, Microsoft Azure, IBM, CDB. And also there are a lot of end users like Hitachi, Akamai, Tembo, and so on. In the repo you can find the operator, but there are also the Grafana dashboard, the Postgres containers maintained from the community, helm charts, CNPGI example, and so on. This is a list of links also from the social part. So we have Slack, Twitter, Mastodon, Blue Sky. And this is a list of more focused on some resources. So there are talks, blog articles related to CloudNativePG. Also, some of the maintainers and contributors are part of the Data on Kubernetes community. That is very important to bring all the database, not only PostgreSQL obviously, into Kubernetes. And now it's demo time. So this is what I'm going to do if we have time. Yeah, I will show all this stuff. Let's start. So it's very big. Let me reduce a bit. Okay. I have just created a kind cluster. Kind is a tool to have Kubernetes in Docker. So basically, I use this script that is part of the operator repo to destroy the oldest one, to create a new kind cluster, and to build and deploy there an image of the operator. So basically, we have a fresh cluster kind with the operator there. Oh. Okay. Let's do some stuff. So I would like to apply this cluster. So it's very, very simple. So the only thing that I added is the Postgres image, because I want to also to run a major Postgres upgrade. So I will start from the 16, and at some point we will upgrade to the 17. So let's apply this. Let me do something here. If you see on the right, I'm showing the pods. We have the init job for the Slovakia -1 pod. And here I want to show you some info from the cluster, our CRD. So basically, they are aligned. And yeah, we need a primary. At the end of when all the pods will be spin up, we define a cluster with 3 instances. We will have a cluster in LT state on the left. And on the right, we are waiting some time to pull the image. We already done it. Yeah, the first pod is up and running. Then we are going to to create the new replica. So I want to show you now the cluster CRD in Kubernetes, what the operator added to our cluster. So let me stop here. If you remember, our manifest was very, very tiny. Then we have a lot of stuff here. If you see here in the spec section, there are some defaults about the initdb, the max-sync replicas, min-sync replicas, monitoring, all this list of PostgreSQL parameters that actually you can provide to the manifest if you want to enforce something different from this default. So as you can see, there is a lot of stuff. And then we have our status saying the name of the DNS, the condition of the cluster that is not ready because we are waiting for all the pods to be up and running, the instance name, the LTPVC, we need the third one. There is just the first two. So as you can see, there is a lot of stuff. That's it. Now, let's see if the cluster is healthy. Yeah, it's in healthy state. So we have all our 3 pods up and running. Now I want to enter a pod and show you that there is Postgres. As you can see, we have a Postgres 16.9. Let's create a table just to something like, yeah. Let me insert a random number here. So I can exit, I can access, for example, the second pod. We can see that also from there we can access. And we can try to create a table from the replica, but it will not work. Let's see if it will not work, because our services is just read-only on the replica, so this shouldn't work. Cannot execute create table in a read-only transaction. Awesome. Now, let's start to play a bit with the plugin. We can get the status of the cluster. If you see here, let me I'm in Tmax. Let me exit from here. Because I want to scroll from the up, and I don't want to remove the colors using less or something else. So yeah, you have a list of information regarding the cluster. For example, the primary instance is Slovakia 1. And now we are going to do some damage to simulate a failover. So we are going to kill this pod just for fun and because we can. So let's delete the first pod. Let's see the cluster. The cluster now is waiting for another instance to become active. He already promoted another one to be the primary, and now it's again in healthy state. So you see it was very, very fast failover. Let's see what is the current The current primary should be or 2 or 3. Here is the 2, the number 2. Awesome. Then, I would like to show you database CRD and to play a bit with it. So let me show you the content. This is our database CRD. The name of the CRD is db-bratislava. The name of the database is Bratislava, the database inside Postgres. And the cluster this database belongs is the cluster we already created, Slovakia. Then I added as extension PG vector. So we can also see the extension already installed once I will have applied this. Oh. Let me enter the pod. I can switch to Bratislava database that is there, awesome. And I can show you the installed extension, and you can see there is vector. If I go back to my Postgres database, you can see the extension has not been created. We can add it because it's there in the image. We can do something like that if we want. It's poor Postgres, this, nothing too fancy. We are okay. I cannot add it because I'm not in the master pod. I can do it in the master that we know is the second one. And that's it. We also have PG vector here. Okay. Now, I can show you a measure Postgres upgrade. Why not? Let's edit our cluster. Again, let's see the cluster. Oh, there is this new status, upgrading Postgres major version. Let's take a look at the pods. There is the pod of the measure upgrade that is running. And then we will need some time to see this in action. Meanwhile, let me think if I can show you something else. Yeah, I have an idea. For example, I can show you some of the logs of the operator. If you can see, these are the JSON log that I mentioned before. So basically, the operator, the level is debug, but you can edit. You can have just the info, or you can go also with trace. So you can adjust the log to be more or less verbose. And it's continuing to scream and write stuff. Let's see our pods. We have one pod, Slovakia 2, the primary, then Slovakia 4, and Slovakia 5 is almost up and running. So at some point we will have our phase that should be clustering empty state. I can already show you that if we enter Postgres, now we have the 17.5 version, so we upgraded the measure version, and good luck to do it manually with Postgres and not use an operator or something automated. Another thing that I can show you is that I want to play a bit with back with the database CRD. I want to edit it. If you see here, we have a database reclaim policy that is retained. So basically, if we remove this CRD, the database still exists in our database, in our Postgres. So I'm going to change this. I want to apply a more nasty delete. So when I will remove the database CRD, we can also enter the Postgres, and we can see that there is no more Bratislava. So bye-bye Bratislava. This is the end of the demo. So let me go back with the last slide here. Yeah, this is the last slide. If you have any questions, I will be happy to answer. Okay. So the first one, I think I show you.
Exactly, you already showed it.
It's already supported with the base image. But basically, you can add the extension that you want inside the image. There is a way to build your own image that is compatible with the CloudNativePG operator. And there is a nice blog post from one of the maintainers, Jonathan Gonzalez, that show how you can do this. And PostGIS extension, that is one of the most famous, we have the container images maintained from the community. So there are examples. And also you can ask on Slack, on the CNCF Slack of CloudNativePG, and you can receive help from people that already have done this stuff.
What is the recommended way to do CNPG backup?
Yeah, I put the backup out of the demo, otherwise I will take perhaps all the demo time, but I mean, locally with Min.io you can test it. The current way to perform backups is via Barman. We have the Barman Cloud plugin. Historically, we had the Barman Cloud stanza inside the spec of the cluster, but then has been deprecated in favor of the plugin, so that basically also the plugin and all the future backup plugins will be something that you plug into the operator that won't have any other executable, because historically Barman was part of is still part of the image, but will change the permissions. So it has been refactored. Is something that we are working currently. But yeah, currently with Barman, and another way is with the volume snapshot CRD. So one of the maintainers of CloudNativePG is also part of the SIG storage. We work a lot with them, with the SIG storage of Kubernetes. And basically, relying on this CRD, you can perform a way faster backup, because you restore directly the snapshot, relying on the volume snapshot CRD and volume snapshot content. So we support both.
There is a complementary question. What is the recommendation for CNPG cluster restore?
Okay. Again, actually we use the Barman Cloud backup, Barman Cloud backup command under the hood. Barman Cloud, the analog is Barman Cloud restore. So you can define you can define this object to be consumed by the plugin, the object stored, or you can, for a few months, again, still continue to use the old-fashioned way to declare inside the spec your basically, when you restore a cluster, you are declaring a new cluster, and the source won't be the initdb, but an existing source of backup. So you can start from a backup, and we also support the point-in-time recovery. So there is a lot of granularity and things that you can tune when you restore and apply a backup.
Can you mention what are the typical pod termination times in Postgres-friendly kube cluster to limit the risk of corruption? How are the operations typically different compared to a stateless microservice cluster?
Okay. I can suggest that you can test it, but I can tell you how. That is very simple. So basically, we provide two different features, but are two sides of the same medal to me. They are called hibernation and fencing. With hibernation, you can suspend all the Kubernetes around Postgres. So basically, you can go and debug your own objects. The fencing is quite the same, but you shut down gracefully Postgres, and you have Kubernetes. So basically, we offer you the way to gracefully shut down these objects, and you can measure it. I don't have a clear answer, but perhaps there is something inside the documentation. And also we show how you can test EV workload with PG bench and so on. So yeah, this is a nice question.
Is it possible to downgrade Postgres version? Upgrade seems to be straightforward enough.
I never tested. I think not. I will be very happy if our book will prevent it, because if it doesn't mention, I'm not sure what can go wrong. But you can historically you can change also downgrade. I think a minor version. This is for sure. You can upgrade to a minor version without any downside, without relying on all the procedure to do the major version upgrade. According to the documentation, it shouldn't be possible.
How complex task is to recover a database from backup? Is it possible to do a recover to some point in time?
Definitely, yes. Yes, with Barman you can do it. With the operator relying on Barman. Sorry.
What is the recommended way to do downtime-less upgrades of Postgres?
This is not with the offline upgrades like the one I showed, but with the online upgrades. So basically, you should set up the logical replication. So basically, beside the database, you should set up subscription and publication and subscription, and you can achieve this with the logical replication, because you will have two clusters and you can start to upgrade one of them.
And the last question, we are out of time. If we change a parameter directly in the file rather than in the live manifest, is the cluster CRD smart enough to apply that change to the live manifest automatically without recreating the cluster or throwing an error?
Yes, definitely. We have a declarative management of PostgreSQL parameters. Some of them will require the pod recreation. Some of them not. You can apply them live on Postgres. But you don't have to recreate a cluster. An example, very, very huge example is when you change your image. You change from a minor to another minor, you are changing the image, you have to recreate the pod. Some other parameters you can directly apply it. If you have a replica and a source cluster, there are a lot of things to do, because some parameters should be changed in the replica, some others should be changed in the source and then in the replica. So there is a lot of mess around that.
Thank you very much.
Thank you.